So, hello again. This is another tutorial on how to use Go in robotics. The framework we've been working with is known as Gobot, and the idea is to make a little robot using an Arduino and a Raspberry Pi and this library in Go. So we've seen so far how to control a servo. We saw how to do some face detection. Now, in order to finish the prerequisites, I'm going to show you how to control servo motor. So it's quite similar to the previous tutorial, so I'll try to go quite quick. So what I've printed out, so I've shown you previously, I'm going to show you here. I've shown you previously that I've printed out this little tower with the infrared pi cam. We've seen how to use the servo motor. Now there's a stepper motor underneath, and the idea is that this will rotate the camera. It's a much smoother move, but we do need a little switch on the side to, just like 3D printers and all that, just to tell it where's the 0 point. So you can find the files on Thingiverse. I'll put the link in the description where you can print the different bits. And the idea now is to plug in this servo motor using this little circuit here. Okay, this is a ULN2003AN, and if we actually go into Gobot and we look at the drivers, right, underneath servo there's stepper motor, and there's actually an API to control this little circuit. Okay, so first thing we need to do is plug in everything. So I got the cable for the servo which is underneath. So I'm going to plug this in, and maybe just cut there. So we need 4 cables for the inputs and 2 cables for power. So all this can be plugged on the Arduino. For the resistor, I've made this little stupid thing there in order not to solder anything. So I got you need to put a resistor, otherwise you just short circuit the thing. So this is not ideal, but for prototyping it's good enough. And I'll put this in pin 4. Here we are. So my setup is a bit messy. I can show you if I just take the camera. So we've got the little circuit here from where the servo is going. I got the switch plugged in. So the red and yellow are positive. I got the servo which is plugged into the 5 volts. The switch which is plugged into 3.3 volts, which I guess would be enough. Ground and ground for the switch and for the stepper motor. I might confuse stepper and servo, but this is just for stepper motors. And finally, all the in, which are here, are plugged in on these 4 inputs, and the resistor is directly put into the pin number 4. So again, it's not ideal, but for what we want to do, it's good enough. So we are now into the IDE. So I've made this new folder in which I put a main.go file, and this is going to be the same as the previous tutorial. It's just going to be the master file, but instead, and we just keep it as is. Okay. Then we make a second file, which will be arduino robot.go. I'm just going to copy and paste what we did last time because it's very similar code. Okay. Now, first thing we want to change is, instead of using the servo driver, we want to use the stepper driver. So it's stepper. So we give it the FA adapter. And now for the inputs, the first input is a slice. It's not a slice. An array of string, length 4, which are the different pins for the stepper motor. So we are plugged into pin 7, 8, 9, 10. Then we give it the phase of the motor. So in my case, I'm using, I'll put in the description the type of motor I'm using, but it's a dual phase. So we put GPIO stepper mode, dual phase stepping, and finally the number of steps to make a full revolution, which is 2048. This is according to what I found online. I'm not actually sure, but it worked. Great. One thing is, because these numbers are not well documented, I mean, they're in the documentation, it only states that we need to put this type of array for the pins, but it doesn't say which pin is what. So we might need to change these numbers if the stepper motor doesn't turn around in the right direction, or if it just doesn't move at all. So we'll see that later. So we're just going to rename this as stepper and rename the robot. We can put stepper in here. So yes, so the work instead of servo manager is going to be stepper manager. We give it stepper, and the robot renamed this as stepper instead of so again stepper. Work in rewritten robot. So this is done for the stepper motor. I'm just checking my notes. Okay, so now we need to make the stepper manager function. So I'm going to delete what was in the servo manager function, rename this. Again, to determine what the type is, even though I guess it should be stepper, we can see if this crashes later on. First thing we want to do is do some sort of initialization to basically rotate the stepper motor until it hits the switch. Because if I go back into the design, here there's this little arm. Can I see it better? No, yeah. There's basically this little arm on the 3D printed arm that will hit this switch when the camera is aligned. So we'll be able to rotate from this, which is the 0 point. So first thing we want to do is to rotate until we get a positive value on this switch. So for this, we will actually need to pass the second argument here, which will be the formatter adapter, which will help us read a pin, whether it's high or low. There's a little bit of noise in my house. Do apologize about this. Can't do much about it. So we want to get this adapter, which we'll need to pass here, FA. And first thing we want to do is let's type println and we init stepper. Okay. And now making a lot of noise. I don't know if you can pick it up, I hope not. Anyway, so what I was saying is that we need to make a for loop that will rotate until it hits the button. So for hit error, so this is going to be the variable to read, do a digital read. So it either gets a boolean either true or false. So digital read, and we want to read pin. It was pin 4. If we get an error, we need to deal with it. So if it's not nil, panic, or just no, it's just panic, and could not read pin 4. So now we read this pin. So what happens if hit is equal to 0, then that means we've closed the circuit, so we've hit the switch. So what we can do is stepper, move it minus 300, which will basically turn it back in the center after hit the switch, so it doesn't just stay where the switch is hit, just go to a value which we know of, and then we just we break, so we break out the for loop. Else we move the motor, so stepper, move, and we move it in increments of 10. So 10 pulses is quite low, it won't move much, it won't move fast enough for it to be like rapid, fast enough basically, but not but basically it won't crash into the switch if everything goes well, because it will crash into the switch at some point. So this is the initialization. Once this is done, we can basically just do some sort of loop just to move it, let's just say, just move it like 5 times, as we did with the stepper motor. So from 0, I equals 0, smaller, then let's do it 10 times, I plus plus. So what do we want to do? We want to move it, let's say 10, let's do 50, and then do this again, so minus 15 plus 50. Okay, so this is going to initialize the stepper motor, put it back into a center-ish position, then move it 15 pulse on one side and 15 pulse on the other side. So let's try this out. Go run everything that ends with go. Stepper is not identified, so yes, of course, because this is an S instead of stepper, so let's just write stepper here. Line 11, fermata is undefined. It's here. Okay, first we can comment out time. So this is undefined. 911, fermata. Ooh, fermate. Okay. Oops. So let's see. Okay. So what happened right now, if I take the camera again, is it rotated in the wrong direction. Instead of going towards the switch, it went to the other side. So what I'm going to do is go down back into the code and maybe invert these bits. So let's see if this works. You need to be ready with a Control C. Okay, it switched, it went back. Okay, so it went back a little bit too much for my taste. Let's do 100 here. Okay, let's run it again. Okay, it switched. Okay, so it works, but as with the stepper motor, I need to repeat this bit a few times. So 0, J, smaller, let's do it 5 times. J plus plus, and let's and this. And we don't care about the indents. Okay. Exit. Let's try again. Here we go. So it works fine. It's a bit laggy on the stream, but this is the idea. From there, we can programmatically control how it moves. We got a safety switch on the side. We can determine how far it needs to rotate before it hits behind, or this bit. It actually hits this bit on this model, but this was fixed in what is available in the Thingiverse. So, okay, everything's falling down. I don't know what's going on. So I'll end it. So I will end it here because my setup is struggling. I don't even know if the sound is synced up. So if you have any questions or remarks, you can put them in the comments. If you need to subscribe, well, you know how to use YouTube. If you have any questions, you can go on GitHub where you can find the code and post issues over there. Anyway, in the next video, we'll see how to follow the face, because we've got all the tools we need to follow the face. So I'll see you later. Cheerio.